ఓకేనా? ఓకేనా? సార్ గుడ్ మార్నింగ్ అండి. ఆడిబుల్? హలో 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 గుడ్ మార్నింగ్ డియర్ స్టూడెంట్స్, వెల్కమ్ టు ఓకే అని అడుగు రంగనాథ్. ఓకే లేదా బాగానే వస్తుందా లేదా? వెల్కమ్ టు స్టూడెంట్స్ ఆఫ్ సివిల్ అండ్ మెకానికల్ ఇంజనీరింగ్ ఫర్ గేట్ కోచింగ్. The subject for engineering mechanics. The outcomes of this subject is you are going to learn how to solve the static problems and dynamic problems. If you take any system in a real scenario, it is you have to treat as a static condition or a dynamic condition. In a dynamics, we have so many types that I am going to explain. So that means the main outcome of this subject is not only the gate coaching, in real life, wherever you are working in future, this subject is going to use in both in the course sector as well as software sector, like in software modeling simulation. This is one outcome, main outcome of this subject. The second one is some of the tips we can use to solve problems very faster way, like in competitive exams. One is or higher education, like GATE and other things, engineering service, civil service, etc. UPSC, all exams. This is another outcome of this subject. Everywhere it is there, and this is the extension of your physics, what you have studied in your intermediate level. That's why you have to apply those principles what you already learned to solve the static problems and the dynamic problems. This is one of the main important subjects for civil engineering as well as the mechanical engineering students. Today I will mainly concentrate on because this course is planned for 12 lectures. Today I am concentrating mainly on the fundamentals. Once you know familiar with the fundamentals, then you can easily understand the remaining concepts. That's why today, most of time, more than 1 hour, I am going to concentrate some of the fundamentals wherever we are using. That we should not repeat again. Then we will try to discuss what are the different force systems which we are using, types of forces, etc. What are those systems? Force systems, then the concepts of equilibrium. If time permits, then we are going to discuss the degrees of freedom. That is also one of the important concepts. That means you have to know the mathematical skills from this subject. You know the mathematical skills, how to apply in the real system. Suppose an accident has taken place. The vehicle has collided with some other vehicle or with a passenger or with some tree, whatever it may be. That data you can analyze with the help of this subject. Then you can identify the problem belongs to which vehicle or which person. These all can be analyzed. That means the final thing what I want to say, any practical problem can easily analyzed with the help of this subject. But every system has some limitations. Here also, this subject is also you will have to start with some assumptions. Okay. So now let us start with the mechanics is generally classified as theoretical mechanics, applied mechanics, experimental mechanics, and computational mechanics. Because nowadays all of you know We are pioneer as in India in a computational, that is digital era or digital technology or ICT enabled technology or computational technology. That's why a lot of job opportunities are coming for our youth because of a lot of demographic development in our country. We compare with the theoretical mechanics is basically a science like physics or chemistry or like that. You have to develop a theory which should be universally acceptable, whether in India or European country or Western. So the applied mechanics is nothing but the engineering or technology. By application of science, if you want to solve the problem, that is what is called the applied mechanics. Then experimental mechanics. That means nowadays most of the people are going computational mechanics, but there is another important in the experimental mechanics. You have to develop a scale model or a prototype model or actual model. Suppose if you want to analyze the watch component, you have to enlarge the scale. If you want to analyze the aircraft, you have to decrease the scale. So like that, sometimes the actual scale depend upon the develop a scale model or actual model and try to test it in a real condition. Apply static or a dynamic nature portion and try to analyze it. That is what is the experiment. But which is the main problem with experimental is you have to spend a manpower, time and money. If you are satisfied with the result, it is okay. Otherwise, you have to repeat that part. Whereas computational is overcome those problems, depend upon the complexity, depend upon the size of the problem. And by applying computational tools, you can solve either in 1 hour or 1 day or 1 week or 1 month. Even if you want to do any modifications, if you are not satisfied with the results, that can be done also in a simplified way. And that is what is these are some of the advantages of computational mechanics as compared with experimental. Or you can simulate in a real life scenario any system. Easily it can be done. Where experimentation, the time is also a lot of manpower, money. These all can be overcome by using computation. In computational mechanics nowadays, the scale size, that is, you can solve macro problems anywhere. That is what we are doing in classrooms. Or micromechanics, macromechanics, nanomechanics, thermomechanics. That means because of computation, any level of digit we can go. Because of that, the mechanics can be done any scale. That is another beauty of this computational mechanics. So that's why this subject is a backbone of any software which we are developing, like modeling and analysis software. Then continuum mechanics is when you are analyzing a system with a real system. You can see here I have given 3 things. One is the solids, then fluids, then multiphysics. Multiphysics is combination of solids and fluids. Solids means when you are considering only like when a ship is traveling in water, you are considered only ship or a submarine. That is what is or an aircraft without surrounding air, or a locomotive without considering aerodynamic force. That is what is only solid we are considering, try to analyze. Static or dynamic. And then when you are considering a fluid separately, just opposite to the solid, that is what is fluid mechanics. And we are considering fluids. Whereas multiphysics is a real life problem, a combination of solids and fluids. So whereas any system is, it can be a mechanical system, or it can be electrical system, or it can be electronic system, or it can be a combination. Like an automobile, we have sensors and actuators as well as IC engine, etc. The system consists of mechanical as well as electronics. That's what is the mechatronics. Like washing machine. Like that we can consider and try to do the analysis. That is what is real life systems. See, this subject is one of the main objective is these are the things what we are going to discuss. Okay. See, then the same thing what I have given in form of, if you anybody want, you can note down definition part. Sometimes these are also asking as an objective question. Theoretical mechanics is it deals with the fundamental laws. That's what I already mentioned. The basic principles of science, like Newton's law, Archimedes principle, Ramjee's theorem, parallelogram law, like that. By conducting number of experiments, they try to obtain some analogy. It should be universally valid. Whereas applied mechanics is by applying those principles which you already developed, you try to transform the system from one form of energy into another form. That is what is applied mechanics. There is nothing but an engineering or technology. That is what all our engineering students, what we are calling BTech mechanical or electrical or civil, these all are engineering. Our objective is to transform the energy from one form to the other form by considering any system and by applying those principles. Whereas experimental mechanics is testing. The real life system, you have to test it under a scale model or actual model or board, any enlarged or decreased scale. Computational mechanics is basically few cases we are using analytical exact solutions, but most of the cases we are using the numerical method by implementing on a digital computer. But here the error is one problem that you have to take care of. Because when you are using a numerical method, it depends upon what type of assumption you are taking, the discrete values, the discrete interval. That is very, very important. That is what is called the computation. Then the examples of computational mechanics, fluid mechanics problems, where liquids, gases with hydrodynamics, aerodynamics. Like ship is traveling in the water, hydrodynamic problem. The aircraft is moving, or a locomotive is moving, turbines. These all we can consider the examples. Whereas multiphysics is a combination of both solids and the liquid or gas. There is a phase change problem or a metal solidification like metallurgy problem. Metallurgy. Ready? Cooling of ICs or a PCB circuit, electronics. Any system can be analyzed by using this. This is what is called the multiphysics problem. Then what are the applications? What type of problems generally we try to solve? One is equilibrium problems. First we have to decide static or dynamic condition. That is one of the fundamental objective of this. In order to decide that, you have to decide whether it is an equilibrium or not. To decide an equilibrium, because we are applying some forces on a system, while considering all these forces, what is the resultant? Magnitude, direction, location of that force. Once you identify, if it is zero, you can say that the system is in equilibrium. Otherwise, it is not in equilibrium. That is what it is. If it is in equilibrium, it is static. Otherwise, it is in dynamic. This is a simple analogy which we are going to apply for all applications of engineering mechanics for the static. That is first and foremost point. You have to decide whether the system is in equilibrium or not. If it is an equilibrium problems, what type of problems we come across? Generally, suppose you take a civil engineering student. The static analysis of structure. Structure can be a bridge, or it can be a shell, or it can be a plate, or it can be a bar, or it can be a beam. Anything. Any structure you can consider, or it can be a tower, or cell phone towers, or it can be aircraft structures, or it can be civil structure, or it can be airport structures. Anything can be considered as a structure. But here one analogy is we have to consider the one-dimensional structures, two-dimensional structures, and three-dimensional. Depend upon that, we have to consider the number of degrees of freedom and number of equilibrium equations. That we will discuss in the later stage. But at this stage, try to understand the main objective, the main concepts. The static analysis of the structure is because generally the problem is very complicated nature in a wave structure. First, we will try to apply static condition. If it is required, we will go for that. That's what the real. These are some of the civil engineering problems. Then aerospace, all aircraft structures like wings, fuselage, fins, whatnot. You can quote number of cases. These are the aerospace problems. Then mechanical engineering problems. Steady state temperature in solids and fluids. Heat transfer problems. Machine design problems. Like that. That's what I mentioned, machine design. In the machine design again, stress concentration, where there are high stress, high region of stress, localized stress takes place. Or stress analysis of any machine member. Again, here it can be a one-dimensional, two-dimensional, three-dimensional. Any composite materials nowadays which we are using plenty, metal matrix, ceramic based, polymer based composite materials, or nano composites. These all we can try to analyze. Then biomedical. This is one of the important area because the doctors are very busy. As an engineer, we can do some help in this direction because here bones, teeth, the heart replacement, implants nowadays which we are doing, and that is high cataract operations or heart valves. Like that, you can quote number of kidney transplantation. Because bone strength is different from person to person. Teeth strength is different from person to person. That's why we have to do the stress analysis. That is, we have to do the static part and dynamic part. Based on that, you have to decide what is the strength of the bone. If you want to replace or if you want to fix something with mechanical, like bolt and nut and other. That's what the doctor is doing. But as an engineer, we can do that. Suppose a person is suffering from heart attack. Through, like our blood is flowing through vein. If you consider the cylinder by applying internal pressure and external pressure, and you try to do the analysis, this is like a mechanical control. Similarly, the bone considered a one-dimension, two-dimension, three-dimension structure. Try to do the static condition of that. This is again a civil or a mechanical control. Like that, we can consider the real system. This is one of the upcoming area. A lot of job opportunities are there. Now, the eigenvalue problems. This is the dynamic nature. For any problem, you have to decide whether it is a mode shape and natural frequency. Based on that only, we try to avoid resonance, high amplitudes, once we know those values. That's our first and again foremost point is in dynamic nature. When you want to do the dynamic analysis, we have to do the free vibration and forced vibration. Eigenvalue problem is comes under the free vibration problem. Simply disturb the system and see what are the vibrations. When it is going to vibrate, what are the mode shapes? Different mode shapes, natural frequencies, and other things. You can consider. The eigenvalue problem is one of the point we have to do in industry. Any component when you want to do before doing an assembly or before doing manufacturing, you have to see what are the mode shapes and different conditions. What are the different natural frequencies. And again, if you consider civil engineering problems like natural frequencies, stability of structures, different mode shapes, the modes of first mode, second mode, third mode. Like earthquake is a phenomena of 1 second or 10 seconds or 15 seconds or 1 minute maximum. Everything is happening. How to do that type of analysis? We quote any number of examples, or a single floor, second floor, third floor, or like apartments. How to do the mode shapes for going to construct. These all we can do by using computational mechanics. Nowadays, the people are doing calculation. In that, we can find out what are the modes and mode shapes, their natural frequencies, or indirectly it is a natural frequency and the displacement, or velocity, or acceleration, or a jerk. You can represent or a force. You can represent in any value as a mode shape. Then aerospace problems. Again, natural frequency, stability of structure, whether the structure is stable or unstable, you can find out. Stability of spacecraft. Aircraft, again, a passenger aircraft or cargo aircraft. These are the things which we can do. Machine design, again, natural frequency, stability of different machine elements like bar, beam, truss, frame. Anything we can try to analyze the stability of the machine elements. Then propagation problems, like time dependent. With respect to time, the input which we are changing, or input we are applying. Stress waves in terms of sine wave, cosine wave, sine omega t, cos omega t. Exact with harmonic input or sinusoidal input. This is another type of dynamic nature. Propagation problems. By considering a periodic load or aperiodic loads. The load which we are applying input is a periodic nature or aperiodic nature. There is different types of input, like transient input, sudden input, time dependent, or random input. Because sinusoidal we are exciting with one frequency, but random we are exciting with multiple frequencies. Some signature. So these all problems can be analyzed, like propagation problems. Again, civil, aerospace, similar condition, then mechanical problems, flow problems, and machine design problems, biomedical, all implantations, or everything which we are going to analyze. Now let us come to before closing this topic, the application part. These are the general mechanical and civil engineering, few electrical problems, combination of mechanical and electrical problems, like design of buildings, stress analysis of buildings, bridges, etc. Fluid flow problems, ship, aeroplanes, missiles and airframes, heat transfer problems, mass transfer problems, electromagnetic field and space capsules, space satellites, where sometimes the electrical and magnetic, which we can consider, soil mechanics problems, civil engineering again, acoustics, electric motors, lubrication, nonlinear vibration problems, earthquake problems, vehicle dynamics, tire mechanics. Like this, we can consider I have listed few, but you can quote any number, any type of this system, which we can do the analysis with the help of this subject. That is the beauty of the engineering mechanics subject. Now, let us come to the mainly mechanical and civil engineering problems. Sometimes it can be linear or sometimes it can be non-linear. Non-linearity, simple. The linear, non-linear is, if you are conducting a simple pendulum analysis, either experimentation, you have done intermediate level analysis of simple pendulum. When you are oscillating a simple pendulum, the equation finally what we are going to get is theta double dot plus E by L sin theta is equal to for free vibration equation. That is to do the eigenvalue analysis. In the G by L sin theta, the sin theta if you can expand, theta plus theta cube by 3 factorial, theta 5 by 5 factorial, theta 7 by 5, like that any number of terms you can consider. When you consider theta, let us say 0.002, When theta cube by 3 factorial point, not like that. At what level you are truncating your nonlinearity? But in intermediate level, we have considered for a small value sin theta is equal to theta. That means a highly nonlinear system we are converting into linear. So that is an assumption. So that's why we have to start with some assumptions. Otherwise, the problem will be complicated, complex. And it is a cumbersome, we cannot get a solution. That's why to simplify that, first we have to start with some assumptions. That is what is the linear, nonlinear problems. How much load the structure can resist. Suppose my weight is 80 kg or 90 kg. How much load I can resist? How much load I can apply on my hand? That is what similarly structure also. Otherwise it collapses. A crane, how much load it can lift without failure. That is one thing which we are doing. This subject is useful to can estimate what load the structure can resist. Then deflection, structural analysis. What deflection it can be? Displacement and direction. Rotational displacement and translation displacement. Slope and deflection. Analysis. Then stability, finding critical points where the takes place like bifurcation of points, the shear force changes, bending moment changing. These critical points we can do the analysis, stability analysis. And then service configuration analysis, like an equilibrium form, like slenderness of structures, like cables, helicords, etc., like springs. We can do this. Then, this is another important point which I mentioned, degrees of freedom. Whenever you are solving any problem, whether it is engineering mechanics problem or a civil, like mechanical engineering or civil engineering or electrical engineering, any engineering, first and foremost point is what type of degree of freedom system we are going to solve. You have to decide. If it is a 1 degree of freedom, you have to apply that number of equations. If it is a 2 degree of freedom, you have to apply 2 equations. If it is a 3 degree of freedom, you have to apply 3 equations. If it is 6 degree of freedom, you have to apply 6. N degree of freedom, you have to apply n number of equations. We apply those number of equations. First and foremost point is you have to find out how many number of independent coordinates. Now independent, that means suppose y is function of x. Y is depending on x. In that case, only one is the degree of freedom. How many independent coordinates? They are not dependent. Required to describe the motion of the system. That is the definition. Degree of freedom. In our subject, engineering mechanics, we are going to solve planar problems, spatial problems, spatial mechanics, planar mechanics, and spherical mechanics. Like that, we have to start with again this assumption. How many degree of freedom we are going to solve? Then, a static problem or a dynamic problem. Again, is it a degree of the planar problems or a spatial problems or a spherical? Like that, we have to come one by one. Before solving any problem, you define all those. It's very, very important as far as the degrees of freedom are concerned. This is what SDOF means, single degree of freedom system. MDOF means multi-degree of freedom system. Continuous system or infinite degree of freedom system. Where you can apply any degree of freedom, that is your choice. A planar means, suppose I am writing something on a blackboard, I am removing with the duster. Then with the duster, if you want to erase the entire part, what I have written, with the help of a duster, if you erase it, you always contact with the plane surface. And what is the degree of freedom? That is what is the meaning of plane condition. The object is moving in a plane. Or when I am teaching in a class, I am moving on the dias. The dias is on a single plane. See, in that case, what is the degree of freedom? These are we are going to discuss in detail later. But that is one point we have to discuss, we have to decide whether it is a planar problem or a spatial. That means how many degree of freedom problem we are solving. A continuous system or a infinite degree of freedom, or a discrete system. Finite degree of freedom. Then analysis. The types of analysis is, which is already mentioned earlier, static or dynamic. In that static condition, we have to analyze the structure by considering a static analysis. Any structure. Dynamic means you have to decide the number of alternatives. Is it a model analysis or eigenvalue analysis? Or transient, sudden input. When you are moving on a road, speed breaker is coming. That is a sudden input. When you are playing a cricket, the ball is hitting the bat. It is a transient. Within a small time, huge earthquake. It is a transient input. Sudden input. Whereas harmonic is, you are applying a, you are exciting a system with a sine form or a cosine form or a combination. Sine like exponential function. E power I omega t. X is equal to x naught sin omega t or y is equal to y naught sin omega t, x is y or x is equal to x naught cos omega t. Or it can be a random input. It can be applied multiple inputs. When a ship is traveling in a seawater, sea wave height is not same every time. Every time continuously same. There is different inputs. That is what is the random input. Our locomotive is traveling on a track, railway track. Can be meter gauge or a broad gauge or a narrow gauge. That is a random input. Track roughness is not good. Similarly, the automobile moving on a road, the road structure, if you can consider, the front wheels, rear wheels, left wheels, right wheels. These all are not unique. Every time it is. These are the random applications. There you can consider. But in our analysis, mostly, as far as your syllabus limitation is concerned, GATE syllabus or engineering syllabus, we are mainly concentrating model analysis and harmony. We don't touch much on transient and random. These are the real life problems. When you are solving a real life problems, generally we try to consider the transient problems and random. But in our subject limitation, focus subject limitation, dynamic condition, we are going to touch pre-vibrational model analysis, that is eigenvalue analysis, and forced vibration in harmonic. We don't consider transient and random. This is again a limitation of our subject, dynamics. Now, the mechanics. What is a dynamic problem? What is the definition? It is nothing but a study of motion. Motion can be a translation or it can be a rotation. The dynamic system. That indirectly is a translation degree of freedom or a rotation degree. Can be done in macroscopic level, microscopic level, or nanoscale level. But any scale can be considered dynamics two types. One is kinematic, the other is kinetic. Kinematics is mainly deals with the space-time relationship. That means space is represented with a translation or a rotational quantity, like a three-dimensional problem. We are generally used to consider a coordinate system, like rectangular coordinate system, spherical coordinate, polar coordinate system. Like that, we consider different types of coordinates. When you are considering a coordinate system, kinematics we will consider space-time relationship. Space is represented with a translation or rotation, like xyz or theta phi psi. If xyz is with respect to time, that is dx by dt is the kinematic with velocity. Again, velocity with respect to time, acceleration with respect to time, yes, like Gams, etc. theory and mechanics. That is what is kinematic energy. We don't consider the mass, we don't consider the force. Kinematic energy. Only will consider the velocity, the acceleration, yes. That means space-time relationship. If we put a theta phi and psi, d theta by dt, angular velocity. omega, d omega by dt, angular acceleration alpha, d alpha by dt, that jerk. Like that we can consider. These are the kinematics. Any sphere, macroscopic or microscopic or nano or terac. In kinetics, not only the space-time relationship, which we are going to consider the both mass and forces. Space-time as well as mass and forces. This is how we will consider the real. That is again the limitation. That means the branch of one branch, the kinematic analysis of a dynamic problem, another branch, the kinetic analysis. We are considering force as well as mass. That is indirectly Newton's law, F is equal to m into u. If A is nothing but a kinematic part and F and M is a kinetic, in addition to E. That is the difference between the analysis, the kinematic analysis and kinetic analysis. We will do both in dynamics, that is there in our syllabus. That means simply velocity acceleration analysis comes under kinematic. Not only that, if you are considering a force and mass also, or not only force, forces, the resultant force. Force meaning is, in our subject is the resultant force. There is a resultant force, the dynamics come to the picture. Otherwise, there is no dynamics. It is static only. In that case, kinetics will come to the picture. This is what is called the dynamic problem definition as well as the, what is the, again, further bifurcation of dynamics is one is the kinematics and kinetics. Then a real system, if you consider that just now what I explained, we have to start with existing structure with the design drawings and data, some input data, structure like length, width, dimension, cross section, etc. Then start with assumptions. These assumptions, just now what I mentioned, what is the degree of freedom, static or dynamic, again in dynamic model analysis, harmonic or transient or random. Like that you start with some assumptions. But as an engineer, not only assumptions, we need some mathematical model. That means an algebraic equation or an integral equation or a differential equation. Whatever the mathematics I studied, you studied, comes under this category. That means these statements try to convert into equation, mathematical model. There's nothing. As an engineer, we need equation. It can be a differential or it can be integral equation or it can be differential again, partial differential equation or full differential equation, integral again, different integral or indifferent integral. Algebraic equation, it can be polynomial, it can be transcendental equation with trigonometric terms. You have to develop some equation. Those statements convert into equation. Then analyze those equations. You have a technique. If it is integral equation, how to get a solution. If differential equation, how to get a solution. If an algebraic equation, suppose x squared plus bx plus c is equal to 0. It is an algebraic polynomial equation. The roots of the equations are minus b plus or minus square root of b square minus 4. That is the solution. But if you can go for cubic equation polynomial, then you have to apply some trial and error, try to get the solution. Some trial and error means some assumption again there is a possibility of error. This is how there are different techniques to try to get the solution. Then solve the problem. This is the step. You have to analyze. Then if a facility is available, test it. If you are happy with the result, send us an output. If you are not happy, we change your design, changes. Then the physical model in the testing part you create because when you want to test it, you develop a model, scale model, physical model. With the static or dynamic conditions you test it. If you are happy with the result, send us an output. If you not happy, you have to again modify this. This will take a lot of time. So that's why nowadays most of the industries, because of time, money and manpower, they are not doing this. Directly you test it with computational tools. If any modifications are required in your analytical model, you do that changes. Then, or if you are not happy with further, again modify these assumptions, change this. Like that you repeat the cycle. This is in a real life scenario. This engineering mechanics we are applying like to solve any. Is very important for any dynamic investigation or static investigation of a complex problems like a cell phone towers, aircraft structures, airport structures, bridges, anything, railway bridges or road bridges, can be done by using this method. This is the pattern which we have to follow. Then other assumptions is very important. In this subject, we are always assuming the problem is in the rigid condition. Rigid means we are taking a particular body. Let us take 2 points on the body. The distance between the 2 points before application of load and after application of load, if it is same, that body is called the rigid body. If that distance is changing, that is what is called the flexion. In real life scenario, there is no question of any rigid body. But if we can apply forces on a body, let us take a chalk piece. I am applying 3 fingers, I am holding a chalk piece. But if you can see under microscope, there is a deformation. But with a naked eye, there is not rigid. Or if I can hold my skin by applying forces, there is a deformation. Flexible. It is like that you start your assumption, whether it is a rigid nature or a flexible. In mechanics also, engineering mechanics, we try to solve a rigid problem. We don't consider the flexible. The flexible problem is for civil and mechanical engineering students, it is strength of material. That is mechanics of material. Whereas the rigid body mechanics is engineering mechanics. So this is one thing. Whether I mentioned or not, always we have to assume as a rigid nature. The body is in a rigid nature. That means the shape is not changing. Always the shape is same. We are not bothering about the shape. Without considering a shape of a body, let us apply the force. By considering forces, whether it is static or dynamic, you have to consider. In that linear and non-linear, once it is a rigid, just now I mentioned,
సార్ ఒక్క నిమిషం అయిపోయింది. హలో సరే అండి. లేదు సార్ క్లోజ్ చేయలేదు.
ఓకే అండి. Sorry for small interruption or treated it as an interval. This is where we are discussing our random problems, like non-deterministic, where stationary and non-stationary problems we are touching. In that stationary, ergodic and non-ergodic, and weakly stationary, strongly stationary. Like first moment, second moment of statistic, like kurtosis, hierarchy you can consider strongly stationary or weakly. Suppose a automobile is traveling in left wheels, right wheels. Left wheel input is different, right wheel input is different. Like that, if you consider, that is what is the ergodic non. These are all which we are considering, but anyway, from your point of view, it is not important. But to give our view, where we are, what type of problems we are solving. We are solving only the upper part, the deterministic. This part of problems only we are touching in your scope of syllabus. We are not considering any of this. Only we are concentrating deterministic, periodic, non-periodic problems. Then, if it is a dynamics, what are the equations? What are the principles which you are applying? One is, very familiar with Newton's laws of equation, first law, second law, third law. Newton's law of gravitation. The three equations which we are going to use: conservation of mass, like momentum equation, energy equation, Newton's law. That means any dynamic problem, sometimes we can solve with the momentum equation, sometimes we solve with the energy equation, sometimes we solve with the Newton's law, with the kinetic and dynamic thing. The crux of engineering mechanics dynamic problem is depend upon the given input in your problem. You have to decide based on the input whether I have to solve the problem with Newton's law or whether I have to solve the problem with conservation of the energy equation, or whether I have to solve with the momentum equation, or I have to solve with the apply DLM's principle or virtual displacement, principle of virtual work, static and dynamic problems you have to consider. These are some of the principles. Some more are there, but these are the principles frequently we are going to apply when we are solving the dynamic problems. Then let us come to this previously explained, but here I want to add some more. The total the scope of the other subjects. Engineering mechanics is a solid mechanics or a fluid mechanics. Mechanics, how many courses which we are going to discuss in your entire engineering career? It can be solid mechanics or it can be fluid mechanics. Solids are static and dynamic, just now previously I mentioned. Kinematics, kinetics. This is our subject scope is start with something like this. Engineering solid mechanics, solid bodies, static dynamics, and kinetic kinematics. This is the only part we are touching. We are not touching a flexible body. This is where your strength of materials, mechanics of plastic, elastic bodies, like mechanics of materials, theory of elasticity, theory of plasticity, strength of materials. This is this part. There is a fluid mechanics. It can be ideal fluid or viscous fluid or compressible, incompressible fluid. Like it can be viscous fluid or it can be without viscosity. Like that we will consider. These are the problems. That's why there are three mechanics which we are touching basically. One is the engineering mechanics, is this part, like this. Strength of materials and theory of elasticity, plasticity, even finite element analysis comes under this part. And this is the fluid mechanics, like computational fluid dynamics, etc. We'll discuss here. These are the three mechanics courses which we are going to discuss in your entire 3 years of engineering for both mechanical as well as civil. But once again I am repeating, We are concentrating on this domain only. We are not touching any of this part of these mechanics forces are different. One is fluid mechanics, another is quantum materials, PDF velocity, finite element analysis, computational fluid dynamics. These are we are not. We are discussing only this domain. Any problem. First we will consider the solid, then we can consider the static or dynamic. If it is a dynamic, kinematics, kinetics. That's all. Subject scope. The same analogy I given in the different. Only thing is I have added the words like PDF velocity, PDF plasticity. The new terms. Up to elastic point is PDF velocity. Beyond the elastic, that means the only difference is if you remove the load here, it regains its original shape. It won't regain its original shape. This is what we are going to discuss the subject, like finite element analysis. This is the fluid mechanics again. The viscosity, if we are considering, is kinematic, otherwise it is a kinetic. Solid mechanics, but again here our part is this is the part, ourselves. We are doing same previous figure and it's almost same. Now let us come to this is very, now I am with that introduction, now I am going to start with the first topic today. Almost 1 hour is completed. Now I am going to touch the remaining part of another 1 hour. What are the different force systems, equilibrium conditions, etc. which we are doing? Please listen carefully here. If you understand this, then the latter part is very easy. Force system. That means nothing but it is a system of forces what we are understanding. The forces are, different forces are there. Like, it can be a point load, or it can be distributed load. Force or a load, whatever it is. It can be distributed, or it can be moment or double. 3 types of forces generally there. Can be a point load, or a constant load, or it can be a distributed load, or it can be a combination of, or moment or a couple. 3 basically. Distributed again, uniformly distributed load, linearly varying load, quadratically varying load, cubically varying load, quartically varying load, quintically, like that you go on increase up to any order, any number, the distributed number. But here I already mentioned, you consider the linear only, the linear distribution. Don't consider the non-linear. That means the number of forces, different types of forces can be applied on a system. Once you are considering number of forces, is it a coplanar or a non-coplanar? The meaning of coplanar forces are, if you are applying forces, whatever, suppose I am considering 6 forces. All 6 forces, I am holding a cell phone with respect to 5 fingers like this. This 5 forces, how I am applying? That is this part of force systems. A coplanar and non-coplanar. A coplanar is these 5 forces are lying in a single plane. I already mentioned planar and spatial. If all the 5 forces are lying in a single plane, that is what is called the coplanar forces. In the same plane, 2-dimensional. A non-coplanar is all the forces which you are considering not in a single plane. Can be any number. Or it can be parallel planes also in a coplanar system. Later we will discuss in detail. Again a coplanar, it can be collinear or concurrent or parallel, non-concurrent, non-parallel. I will show you the examples later. I will discuss what is collinear force system, what is the concurrent, what is the parallel and non-parallel. That is the upper part of this figure. Again non-coplanar. Basically coplanar means 2-dimensional, non-coplanar means 3-dimensional. That's all. That is simple. Non-coplanar means number of planes. That is mostly is a 3-dimensional problem. Coplanar is a 2-dimensional problem. Sometimes collinear you can consider the one-dimensional problem. Coplanar comes under 1D, 2D, and then non-coplanar is always 3D problems, the spatial problems. Coplanar is planar problems, non-coplanar is spatial problems. In the non-coplanar also, there is no question of collinear is coming to the picture because collinear is one-dimensional. Concurrent it will come, parallel forces will come, non-concurrent, non-parallel. If I have given this figure, if you can see, there are 4 forces are acting on 4. If you consider these forces, this is in one plane. If you draw a plane like this. If you are considering these forces, this is in one plane. If you are considering these forces, this is in one plane. If you are considering these forces, this is in one plane. If you are considering these forces, this is in one plane. Like that, the forces are not all are not in a single plane. That is what is called the non-coplanar. Best example. If all are lying in a single plane, it is a coplanar. You do the once it is done, the first and foremost point you have to decide whether you are solving a coplanar system or a non-coplanar. That is a 2-dimensional or 1-dimensional or 3-dimensional problem. Because based on that only number of equations are changed. In the bottom part of the figure, that's what I mentioned. The coplanar is planar, non-coplanar is spatial. It's a planar and there is a spatial. But only extra thing which I added the word, instead of non-concurrent, non-parallel, sometimes general force system which we have considered. And parallel again, like parallel and unlike parallel. The two forces are acting parallel nature, but both are in the same direction. It is a like or it is an unlike. Okay. Then the remaining non-coplanar is same. Concurrent, parallel, non-concurrent. Both the analysis are same. Only thing, this part I added here, like and unlike. Parallel can be again a like or unlike parallel. So this is what a coplanar, collinear. Again, coplanar, collinear. Coplanar means it is acting as a 2-dimensional x and y, x-axis, y-axis. It can be only, these forces can be acting only in x direction or only in y direction or some inclined. By any kind of direction we can consider. Because force is having a magnitude as well as a direction. That's why if it is acting in x direction, direction is 0, theta is 0. If it is acting in y direction, theta is 9. Like that we can consider. But see all these forces. Best example is some persons, the tug of war, the wire, rope, there are some persons pulling from one side and another group of people pulling from other side. That is the best example of a collinear force, coplanar collinear. All forces lying in a single plane and they are along the same line of action. Whereas coplanar concurrent is, there are 4 forces. I am holding a chalk piece or a pen. I am holding like this pen. The 4 forces. If all the 4 forces or 4 fingers are intersecting at a single point by acting in the same line, same plane. If it is not in the same plane, then it is a non-coplanar. That is, if all the forces acting in a single plane intersecting at a single point, that is what is called coplanar concurrent forces. Then third case is intersecting, coplanar, concurrent and collinear. All are satisfied. That is how we will consider the first 2 conditions. Third condition is coplanar parallel. All forces are in a parallel line. F1, F2, F3. Then the 2 examples are given, C and D, coplanar parallel forces. Like this is a civil engineering problem, a beam, simply supported beam or any beam, overhang beam or a proper cantilever or cantilever, continuous beam, overhang beam, any beam if you can consider the loads of this nature is called the parallel force, coplanar parallel. Or if you can consider these 3, F1 and F3, if you can consider it is a like parallel force. F1 and F2 if you are considering unlike parallel forces. If F2 and F3 if you are considering here, this case, F2, F3, unlike, that is unlike. F1, F2 unlike. F1, F3 like parallel. Like that we can consider forces. Then non-coplanar, non-concurrent. Just now a chart piece, this is the best example. 4 fingers intersecting at one point, concurrent, but they are not in a single plane. They are in the different planes. That means the orientations are different forces. Those are called the non-coplanar concurrent. Whereas non-concurrent, non-parallel is all are not parallel, all are not concurrent. There is no common intersecting point. Two forces may be parallel, but all are not parallel. Like this, if you are considering any problem. Non-parallel, non-concurrent. There is no intersecting point, there is no parallel. All 4 forces, same 4 forces. Everywhere, see, if you are considering 4 forces, if there is no parallel nature and if there is no intersecting point. That is what we are calling the non-concurrent, non-parallel. Like this in a real life scenario, if you are facing this type of situation, you accordingly have to classify your force system. That is what is called the force system. I will show you another example also, you can clearly understand. This is from Nilesh, the textbook. Here, the coplanar concurrent, coplanar non-concurrent forces and the non-parallel, this is the coplanar parallel forces, all are like forces, all are in the same direction. Coplanar non-collinear, they intersecting but not collinear. These are the collinear forces. These are coplanar parallel, coplanar like parallel forces and unlike parallel forces. Unlike means if you are considering these two at a time, or these two. But if you are considering these two at a time, it is again a like parallel force. Non-coplanar, non-concurrent. The different planes x, y, z, all 3 directions. It is non-coplanar but concurrent. All are intersecting, but there is not in a single plane. It is in 3 dimensions. It is also non-coplanar, non-concurrent. There is no common intersecting point. There is all are acting in a 3 dimensions, not a 2 dimension. So this is how we will consider the different force systems. That's why the engineering mechanics problem, first and foremost point is to find out what type of force system we are going to do. Simple way, is it a 2-dimensional or 3-dimensional? Indirectly speaking, is it the 2D problems or a 3D problems or a planar problems or a spatial problems? Accordingly, we try to create an environment and equation set up like that. For that part, you should define first what type of force system which we are going to solve. Very, very important. This is the first topic in your syllabus. If you can see that you can go through the GATE syllabus, the first topic which we are going to discuss today is take any system, apply forces first, then decide what type of force. What type of force means, is it a concurrent, that is a coplanar collinear, coplanar or non-coplanar? Again in coplanar, is it collinear, concurrent, or coplanar collinear concurrent? Like that combination, you have to decide first. What type of force system problems which we have because then based on that only we decide the number of. That's very, very important. This is another point. Always we have to define what type of force system which we are going to solve. This is the first and foremost point in engineering mechanics problems. How many forces we are considering first? What type of forces? There is a concentrated mass or point load or a distributed force or distributed load, or it can be a moment or a couple. Two forces can like or unlike parallel forces support generally form a couple. That is also considered one classification of moment, force into distance. how we try to solve the problem. We have to consider the number of cases. This is what I explained. Now a force system, same analogy. The previous one, force system, coplanar, non-coplanar. Once again, repetition part. This slide in other way. Coplanar, non-coplanar, again coplanar, collinear, coplanar, parallel, coplanar, concurrent, non-concurrent, etc. Like that we try to answer the problems. But only why I am repeating this part, here collinear combination is there in the coplanar, but only change here there is no collinear combination, non-coplanar. But this is how we will try to differentiate the problems with the coplanar and the non-coplanar. This is the first part of the presentation. Now I am going to touch this is what is the first part of the presentation of force system. Now I am going to take an equilibrium with another PowerPoint presentation. If you have any questions, please pass on to Prof or anything that will send the mail. Because now a lot of students are there online for without any in between disturbance, in between inconvenience. We are continuing our lectures. If you have any doubts regarding or any questions, we pass on to team members are there already. They have given details. You have to send your queries. Then we will send any answers to those queries. Now we'll go to the equilibrium. Now let us come to the equilibrium forces. This is what I already mentioned. Applied mechanics is a branch of engineering mechanics. Sometimes we call this subject is applied mechanics because we are applying this mechanics to real life problems. The motion of vehicles like trains, buses, aircrafts, columns, civil engineering, buildings, columns, walls. That's why it's a branch of applied mechanics. Applied mechanics is a standard term, is also called the engineering mechanics. Branch of engineering deals with the then is again once again brush up your knowledge. These are the problems which we are going to consider: statics, dynamics, kinetics, kinematics, whether it is civil or mechanical engineering problem. Another important point now it is a physical quantity. Any quantity which can be measured is called a physical quantity. There are two types of physical quantities. One is the fundamental basic quantities or a derived quantity. Fundamental basic means the mutually independent quantities are called fundamental or basic quantities. Whereas derived quantities are which can be expressed in terms of fundamental. Basically, the mutually independent quantities are called the fundamental or basic quantities. But suppose, for example, derived quantities, velocity is derived from a displacement. Displacement is x, y, z or theta, phi, psi. Translation or rotation. Again, momentum, mass into velocity. Or velocity again, length by time. Like that, we can consider the derived quantity. Physical quantity can be represented as any of these derived quantities. Now the next part is, these are the units also very, very important to your students. A lot of students, they are doing mistakes, especially in gate exams or any competitive exams. Be careful about this. is fundamental or physical quantity, basically. We are most of times we are going to use mass, length, and time, or length versus time, velocity, velocity versus time. Like that we are going to. And again, other things like other part of engineering like electrical current, density, temperature, the heat transfer problem, etc. Those are not much. Now, the unit system of units are represent these fundamental quantities. Can be a CGS system or FPS system or MKS or FCS. But in our subject, mostly we try to use SI system in this. Length, mass, and time, that is meter, kg, second. Force we try to represent with mass into acceleration, that is kg meter per second square, that is nothing but given. This is how we will consider the as per the unit circles. SI unit of all derived quantities. Then the rigid body concept, again you can solve scalar or vector notation. Scalar quantities like only magnitude, no direction. Example, mass, length, density, work, pressure, heat, and current. That's very, very important. Whether you are using a vector quantity or a scalar. Vector is nothing but both magnitude as well as these all you know very well, but only to brush up your knowledge before going to equilibrium problems. These all you have studied already, even in intermediate you have studied, but only to brush up your knowledge, we are touching these particular topics. Now let us come to the next unit, important part is force. We already given force systems, but now in that one force let us consider. The definition is it can be defined as a push or a pull with either changes or tend to change nature of the system, state of rest, or it can be uniform motion of the body. Force is a vector quantity. Why? Because you know very well force, you need three things. One is magnitude, another is direction, third one is the point of application. That is nature of the force or something. Whether force push or pull or point of application, nature of the force. These three parameters are required to decide the tendency of each single force. Where there are n number of forces, each force we require these things. Once again I am repeating, it is a vector quantity because always we are doing analysis with the forces. Below one figure is there if you can see. On a block A, I am applying 50 newtons at the inclination of 30 degrees at point A. See, these are the three things that are important. One is magnitude is 50 newtons, direction is 30 degrees from the x-axis, and point of application is at A. These are very, very important three parameters to characterize your force. Always. If it is unknown any of this, you have to keep that as an unknown. That's why to represent force, we need these three things. It is very, very important as far as the force is concerned. Now let us come to the effects of forces. A force on a body have the following effects. It may change the state of rest or uniform motion of body. The first law, every body may be in the state of rest or may be uniform motion unless there is no explanation. Effect of force. It may change the direction of motion of a moving body. It may change the shape, internal stresses in the body. It will come under not the rigid body mechanics. The shape is changed. But that can be happened. It may produce internal stresses in the body. Suppose if you apply on my head 100 kg, whether I can resist or not, and the body shape is also changed. Internal stresses on bones and on all your human body components are changed. That is what is the. But 3 and 4 we are not touching in this particular circuit. Won't come under this category. The material. Here we are considering only 1 and 3. It may change the state of rest or maybe uniform motion of the body, or it may change the direction. There are two different methods to represent a force. One is vector representation. In this method, force is, suppose if you see the graphically, we can represent a vector representation. Here, you can see the force of 50 newtons applied at the inclination of 45 degrees with respect to x-axis, positive or negative x-axis, depending upon that. Same thing you can do with the Gauss notation also. Use a method of designation of force for writing two capital letters on either side of the force. The marking of capital letters can be done either in the clockwise or anti-clockwise direction. Suppose there are three forces acting. That is A, B, C. We represent like space diagram or a vector diagram. Suppose if you consider this is one force by the particular direction, this is one force and this is another force, the A, B, C. Now A, parallel to this force, magnitude, direction, I am drawing a vector starting from this particular point. Then let us assume that these three forces, magnitude, directions and point of known to you. That is what the meaning. Then only we can solve the problem. Otherwise, we cannot solve the problem. That means this value, magnitude, direction, and the point of application is known to you. This is also known to you, and this is also known. That assumption we are starting the get the solution. If suppose this is the magnitude and direction with some scale, we are drawing one vector here. Then parallel to this, because we know this point as well as this point. This is nothing but OB, this is nothing but AC, and this is nothing but let us say OC, OB, OA. And once we know this point and this point, parallel to this line, passing through this point, draw one line, keep as it is. Similarly, parallel to this, passing through this point, where these two are intersecting, that is the now with respect to this scale, you measure this length and this length, find out the magnitude as well as direction with respect to x or y axis. That is how we can determine the diagram in some notation, Gauss notation, or any other like parallelogram law, like four forces, Lami's theorem. Like that, we can try to apply different principles. Or another point is, suppose a polygon is forming like a vector diagram is getting like a closed polygon, the three forces, then we can say that this is equal. That's what we mean. Like A to B, B to C, C to A, if it is closed. By chance, if it is not closed, then we can say that it is not equal. That is simple logic. The philosophy which we are using, decide whether it needs to be in system or not. Whereas in the earlier case, suppose this is a problem, the first case and vector notation, you can resolve the force in x and y direction, get the resultant, that is sum of force. Here only one force, but there are a number of forces are there. Resolve all forces in x direction and y direction. Find out some of the x forces, some of the y forces. The resultant is sum of the fx square and fy square. The direction also find out. That is analytical. If the resultant is 0, then we can say it is an equilibrium. That is finally what I can say here. You can solve the problem by analytical method or by graphical method, like polygon. But main objective of this is to determine the resultant. Polygon is closed, you can say that the system is in equilibrium. If polygon is not closed, the system is in the given system dynamic condition. That the part which is not closed, that length and the magnitude and direction the body. That is a simple law. That for that purpose only. That means first you have to determine the types of force system, what type of motion it is, direction of motion, the body. Then equilibrium. To decide an equilibrium, we can use analytical method or we can use a graphical method. This is what I am going to explain. Take any problem, first you represent number of forces that are given. What are the magnitudes are given, directions are given, point of application. If anything is unknown, keep as an unknown. What are the input parameters you define first? What type of force system? Then what are the inputs are given each force? Magnitude, direction, point of application. Like that you have to write any, for every problem you write the input. That is very, very important. Once you know the input, then what methodology we have to have. You can easily find out. Then we will go to the another, this is already explained, several forces like F1, F2, F3. This is a coplanar and concurrent force system. 4 forces are acting on a body. Again, this is already explained. I will concurrent can be sometime because collinear also, some people they will classify concurrent forces. Again, collinear and because 2 forces also intersect non-collinear forces. The remaining already explained the previous. I will skip. Now another important point is free body diagram. For any mechanics problem, first and foremost point is you have to remove all the constraints. By removing the constraint, here if you can see the problem, this is here the 2 supports, one vertical wall, one inclined floor is there. The 2 bodies are resting. There is O1 and O2 at the contact point of BC, the inclined wall, and with the vertical wall at point E. Now we separate all constraints, remove all constraints, the vertical wall and horizontal wall. Apply equal and opposite forces as per Newton's law. That is how there are reaction forces here. I removed this wall, but here there is an equal opposite force that I applied here as per Newton's law. These are the one wall. I removed constraint here and constraint here. This again apply equal and opposite force. One force is acting on one, another force is acting on that force which is acting on B. And again here also the O1, 1, 2 surrounding this ball also separated equal and opposite force. That's why there are 4 forces are acting. One is weight, reactive force, this reactive force, this reactive force, 3 reactive forces. This is one load is given acting and 4 forces. Let us assume magnitude and directions are known for with respect to sphere O1. Then with respect to sphere O2, also similarly, these 2 are equal and opposite. Here. And again this reaction. And the weight of O3. Weight of O1 here comes on the picture, weight of O3. Now this is how you have to draw a free body diagram. Engineering mechanics problems, so free body diagram is again very, very important. You have to, once again I am repeating, free body diagram is nothing but remove all the constraints, apply active and reactive force. That's all. Active means what are the forces acting on the body, like weight is an active force. Remaining here weight is an active force, weight of this ball, sphere or ball, where these 3 are reactive force. Here also these 2 are reactive forces between the ball. These 2 are equal and opposite. One is here, one is on other way. And weight, this is the reactive. This is how generally we try to consider the free body diagram. For any problem, this is the first and foremost point. Then law of superposition of forces. Law of superposition means suppose a body is subject with concentrated load, distributed load, let us a linearly varying load and a moment. There are given system of forces. What is the superposition here? What is a linear system? Instead of considering all three forces together at a single instant, whether I am applying three forces, concentrated force or a concentrated load, point load, first. Second is distributed linearly varying load. Third is momentum. If you consider all three types of forces together at a single instant, if you solve the problem, it comes. That's why what I have to do, if it is a linear system, consider concentrated force first case, distributed linearly varying second case, third is a moment. And these three solutions at a particular instant, if you can combine, is what is called the laws of gravity. For linear systems only it is valid. Then the another important principle which we are going to use frequently, principle of transmissibility of force. Name itself, transmissibility. You know very well the force can be considered by applying magnitude, direction, and point of application. The transmissibility means the point of application can be shifted. That is what is called the principle of transmissibility of the force. Here, let us consider the block. This case, I am applying a force F. I want to shift from A to B. Then what I am doing, here I am applying equal and opposite force. There is no change in the system. If we apply at point B here, I am applying equal and opposite force. When I am applying same magnitude of F, we apply at B, this and this will be opposite, that is and this is the only force acting in the direction. The opposite forces will be cancelled with each other, you make it zero. And that means point B, point, I am applying two forces which are same magnitude. This and this will be cancelled, now the only left force is the force I am applying here. The opposite force will cancel with each other. Then that is what is called the transmission. There is no change in the system by considering this principle also. Principle of transmissibility of force. That is, force applying at one point can be shifted to any other place by applying this. Sometimes depending upon the convenience. We can do this. Suppose you have a force system. We have a collinear, you have a concurrent, you have a parallel, like that. But in order to consider force system, I need any one of these. The one force is, if you move like that, you will satisfy any of these conditions by applying it. That is what is called the principle of transmissibility of force. Here I explained two things. One is the principle of superposition, the other is principle of transmissibility. These two depend upon the convenience. To simplify your problem, you try to apply whenever you want. Now the another important some more principles which I am going to discuss today is very very important. You studied already even in your intermediate little bit. A parallelogram law of forces. It states that if two forces are acting simultaneously on a particle, let us say here F1 and F3. Acting F1 is along this axis and F2 is acting along this axis. So the angle between the two forces. That is how indirectly one can say that the two force magnitudes and directions are given. Now our objective is to decide whether it is an equilibrium or not. To decide an equilibrium, that's one. If I want to obtain the resultant force, this is one principle we can apply. Construct a parallelogram by these two forces, because this vector length I know, because given magnitude and direction. Magnitude and direction is also given. These two forces as basis construct a parallelogram. That means parallel to this Passing to this point, draw one line parallel to this. Passing through this point, draw another line. Because these two are equal in length. Length is known to you. Construct this length. And similarly parallel to this, draw another line. So complete the parallelogram. And the resultant force is nothing but the resultant. Joining the other two components. Because it is not perpendicular, it is more than 90 degrees. That's why what we have to apply the general the principle. That is this square plus this square. That is f1 square plus f2 square. And that this is the cos of 2f1 f2 cos. This is how generally we consider the resultant force, even if you can derive that expression by considering the triangle. And the direction is, this is the direction, because this force is acting with this as an inclination. So this is tan alpha is equal to, as per Pythagoras principle, we need 90 degrees here, you extend this, join a perpendicular, this is alpha, this is theta here. That's why the tan alpha is this by this. By using this is what is called, you can find out the f2 sin theta. This is f2 cos theta, and f2 sin theta is the vertical component. The vertical component is f2 sin theta. Opposite side by adjacent side. Adjacent side is f1 plus this f2 cos theta. This is cos theta and this is sin theta. That is how we can use, if you resolve the two components, this is also theta, this is f2 cos theta and this is f2. That's why the opposite side, tan alpha means opposite side by f2 sin theta. And f1 plus f2 cos theta. This is how we can find out analytically, or you can find out graphically directly here. You can, because with respect to scale you are drawing this and this. And the resultant force, with respect to the same scale, you can measure and find out the theta, the alpha. Theta is that is the input are f1, f2, and theta. Three inputs are given: f1, f2, and theta value. Then resultant force can be determined by considering f2, f1, f2, theta. Same input, three values. So this is what is the magnitude, this is what is the direction. You can determine graphically or you can determine analytically. The choice is yours. But always you have these two alternatives are there in any case to solve the problem. Either you can determine a polygon like graphical method, or you can do the analytical method. Both can be used when you are considering any airy mechanics problem. So now let us come to another important principle which we are going to use. Sometimes triangle of forces. Here also it said that if two forces acting simultaneously on a particle represented in magnitude and direction by two sides of triangle, then the resultant is represented. See here, O f1 is given as a vector OA, and this is a given f2. These are the directions, theta or alpha. Let us say one is the input, represent the direction of the forces. f1 is parallel to the x-axis, f2 is making an inclination. That means we know the magnitude, direction and location of the, one is applying at O and another is applying at a point of application. Here, the resultant is represented magnitude direction by third side of both the triangle. So this is f1 and this is f2. Now join the two ends of the starting vector and the ending vector. That is what the resultant is. It is making what let us say an angle alpha. Okay. Now here two unknowns are there. R is the resultant force, magnitude and direction. Two unknowns. Because this force is having a magnitude and direction, this force is having a magnitude and direction, this force is having a magnitude and direction. Because the two-dimensional problems here all are translation quantities, that is forces. So now what we have to do, we can determine two unknowns, R and R. We need two equations. See, for that your trigonometric principle which we already studied long back, we can find out the, by considering this angle is, let us say this angle is this is all, this is theta, this is 180 degrees. 180 minus theta is 180 minus, that is 1. This is 180 minus theta is this angle. This is alpha unknown quantity. Now, F1 with the opposite angle, this is nothing but sine of that is total minus this you subtract. The total angle is angle 180 degrees. 180 degrees minus this. If you subtract, you will get theta minus alpha. That's why this angle is theta minus alpha. F1 by theta minus alpha. And F2 by opposite angle alpha, F2 by sin alpha, and R opposite angle this is the resultant force. You can use that with the sign term. This is what is the principle which we are generally applying when we want to analyze the. Like that, we get number of equations. Here R and alpha is an unknown. You find out that. Now let us consider the coplanar force system. I am holding a pen with 4 fingers. Let us say these 4 magnitude directions are given to you. That is a simple problem. Or I am holding a chalk piece with 4 fingers. F1, F2, F3 and F4. See, now what we have to do is to try to construct a polygon or analytically solve or graphically solve. Again, we have to alternate. Our inputs are F1, F2, F3 and F4. There are 4 forces are given to you. See, now these 4 forces, by considering the forces, you know very well, you decide whether the system is static or dynamic. That means you have to construct, you have 2 alternatives. One is a graphical method, the second one is analytical. Because we know the all magnitude and direction. First, let us use the graphical method. See, what I have to do here, to start with any force, the choice is yours. No question of only you have to start with OF1 or OF2 or OF2 or OF1 or OF3 or OF4, anything you can do. F1, F2, F3, F4. I am starting here, let us, or you can start here. See, now here OF1 is a force, parallel to this, draw one vector, take some scale. Okay, the first vector, you know the magnitude and direction is exact. The second force is given magnitude and direction. Parallel to this, draw another vector. We know the magnitude and direction, fix the length as per this. Then F3, parallel to this, because this point is already, parallel to this, draw a vector. You know the magnitude direction, this length, that means point C also you can identify. Then one more force is there, F4. Parallel to this, because this point is already known to you, draw another vector. Now let us see here, by completing F1, F2, F3 and F4, the polygon is not closed. That means it is like considered in one go, because we have gone in sequential form. F1, F2, F3, F4, F1, F2, F3, F4. Now this is a force the body is moving. That means a given system of, in this case, the 4 forces based on this, now we can say that it is in dynamic condition, not in static condition. Why? Because this system is having a resultant force as well as the magnitude and direction. Now this is the magnitude as per our, because scale is fixed. As per that scale, measure what is the OD length and direction is this angle. It may be 90 or it may be more than that or it may be less than that. You measure this angle and measure this length as per the scale, find out the analytical, that is the graphical solution for the resultant force magnitude and direction. So that means here we have discussed 3 principles. One is the Principle of superposition transmissibility is to simplify our problem, but to get the resultant force, one is parallelogram law, triangular law, second one, Lami's theorem. Third one is any polygon. It can be 4, it can be 5 forces, or it can be 6 forces, or it can be 7 forces, or it can be a number of forces. You have to follow the same principle. If there are 5 forces, F1, F2, F3, F4, or F5, same philosophy you have to apply. If by chance, let us say in this problem, this CD, D is touching O, like this, by chance, then we can say that the system is in equilibrium. There is no dynamic. That is how we have to describe the problem. That means what I can conclude is, first you consider the types of force system, it is a concurrent forces, and also coplanar, all are in single plane. That's why coplanar forces with a concurrent nature. Now that's why I drawn a single plane. First force systems, I know the magnitude and direction, and any resultant force is there or not. Here there is a resultant force. Now we can say that the system is in equilibrium. If it is the resultant force not in equilibrium, if resultant force is 0, we can say that this is in equilibrium. This is how we can apply these three principles. Polygon means any number of sides. It can be a 5-sided, or it can be a 6-sided, or it can be a 7-sided, or it can be a number of sides. That is how the same problem can be solved by using analytical approaches. Analytical means resolve the forces in x direction. Let us say F1, F2, F3, F4. This F2 is making an angle theta 2. This F3 with respect to x-axis, let us say theta 3. From here side or from this side, choice is yours. Minus and this plus like that. And F4 is also either this theta 4 or theta 4. Plus and minus. See, now what I have to do, this F1 you resolve. F1 is, let us assume, parallel to x-axis. F1 is the force in x direction, resultant force. F1 cos F1 plus F2 cos theta plus F3 cos theta plus F4 cos theta. If it is the angle, these are the two angles together. Similarly, the sine, the vertical component. F1 there is no vertical component because coincide with horizontal. F2 sin theta, F3 sin theta, F4 sin theta. That's why I got the resultant force in x direction, the resultant force. Now you have to determine either again a parallelogram law, we can use anything, or because it is a perpendicular, no need of parallelogram law, we can become 90 degrees. You know the Pythagoras principle. The resultant is nothing but square root of x square plus y square. Same parallelogram law, we are putting an angle that is simplified as square root of x square plus y square. See, that is how you can get the resultant force analytical way. And that is the magnitude. And direction is also because the Pythagoras principle. The fx fy angle is 90 degrees. The diagonal can be represented by opposite side by adjacent side. That is sigma resultant force in y direction divided by resultant force. That means this type of problem, again, any problem can be solved either graphical method or analytical method. Graphical method is a polygon principle, analytical method is the resultant force. So the another is, which I mentioned already, Lami's theorem. This is also sometimes, this is the last principle I am going to discuss today. This will close today's lecture. Lami's theorem is, if there are three coplanar forces acting. Earlier we have discussed two forces or any number of forces. Now, if suppose only three forces are there, a coplanar, they are lying in the same plane. Okay. Earlier we already used one, but here some name we are putting, that the author Lami's theorem. He has given this particular answer. Then each force is proportional to the sine of the angle between the other. That is what is the Lami's theorem. Lami's theorem says that if three coplanar forces acting at a point are in equilibrium, and each force is proportional to the sine of the angle between the other forces. That means this force, let us say here three forces F1, F2, making with F3 is alpha, and F3 is making with F1 is beta, alpha, beta, gamma. Now Lami's theorem says that this force is proportional to the sine of angle between, suppose F1 of sine alpha, F2 of sine beta is proportional to sine beta, F3 is proportional to sine gamma. Like that you can make the, okay. This is how we will discuss. Here also again graphical or analytical method. Find out the resultant force in x direction, the resultant force in y direction, magnitude and direction. These are the things. Once again, I will summarize the things. First, what we have done is we have started with what are some fundamentals, fundamental concepts which are very, very important to solve the problem. And when we will consider the problem in engineering mechanics problem, that means the body is a rigid body. Under the rigid body nature, we are considering statics and dynamics, then kinetics and kinematics. After that, we made a lot of assumptions like system is linear system or a deterministic system. Loads are we are considering a periodic or a transient nature, static and dynamic. Like that, we made some limitations, linear system with discrete system or continuous with constant coefficient or varying. Like that, we try to limit our problems. Then what we have done is, after that, fundamentals like deterministic, non-deterministic. Then we consider the force systems. What are the different force systems which we have? Then degrees of freedom. What type of degree of freedom problem which we are solving? In case of force system, we are coplanar, non-coplanar, that is 2D and 3D, or like planar and spatial. That we are given number of classification. Then last point is equilibrium. How to analyze the engineering mechanics problem. I explained the principles like parallelogram law principle, triangle law principle, Lami's theorem, polygon law. By using these principles, you can try to solve the problem practically, or you can try to solve the problem analytically. Here, the both ways you can solve and try to get the resultant force. Right? Our main objective is to obtain the resultant force. Resultant force is there, then only we can decide based on the resultant force magnitude and direction. We try to decide whether it's a static system or a dynamic. And one more concept in between we introduced, the free body diagram. By removing all constraints, apply active forces as well as reactive forces and try to analyze them. Draw the free body diagram. Once you have the free body diagram, you know how many forces are acting, active and reactive. Then in that you decide how many unknowns are there. Because sometimes if you don't decide the magnitude of the force known or unknown quantity, then we cannot complete the polygon. That is the reason why what we have to do is decide what are the known forces and unknown forces. Such a way how many unknowns are there, and depend upon the planar system or depend upon the spatial system, we can consider the number of unknowns we try to solve. So this is how the theory which is called the engineering mechanics. That means as far as your syllabus is concerned today, both mechanical students and we covered two topics. One is the types of fundamentals, then types of force systems, system of forces, then free body diagram, then to decide the equilibrium, what are the different other principles like Lami's theorem, parallelogram law, triangle law, or polygon law. In between, we have discussed the two more small principles like principle of superposition, principle of transmission, to simplify your problem sometimes. These are the exact types of courses. This is what we have touched today. Tomorrow we will try to see some problems. I will explain these concepts, brush up your knowledge. The first half an hour and 1 hour we will do that. Then I will go to the next topic. Once again, best of luck to you for today. If you have any queries, please try to send your Google Forms. Try to send clarification for those queries. Thank you very much for your patience listening of these 2 hours. Even in the teaching learning process, because it's online teaching, if you have any suggestions, please try to suggest. We will try to incorporate those things also. Regarding that also, if you have any suggestions, please tell me. Even PPT also. If you need any specific like animations or anything, that we try to incorporate. Regarding clarity part of PPT, if anything is there, here I think little bit scanning figures problem, but if you have any suggestions, please, it is welcome. Thank you very much for giving this wonderful opportunity for JNTU team, and best of luck to all students who are here online. Thank you very much for giving this wonderful. Okay, stop sharing that.
Stop sharing.
Okay,